So yeah, hello everyone. Today I'm going to present to you some very interesting trends that we have observed in internet routing security. And this work is a joint work with Professor Cecilia Testart and my PhD advisor, Professor Dainotti. So we'll start this talk with a question for you. What do we really know about routing incidents? And by routing incidents, I mean both actual malicious hijacks, but also misconfiguration mistakes, such as fat fingering a prefix. In both cases, an event can end up causing major financial losses, but also at higher scale, it can impact national security. And unfortunately, about these events, the most knowledge that we have comes from some anecdotal evidence and analysis of very few events that, due to their high scale, they make it to the news. So in order to illuminate the BGP incident space, we have built GRIP. GRIP stands for Global Routing Intelligence Platform, and it is a BGP incidents and detection monitoring system. GRIP has been running at Georgia Tech for the past 4 years, and it is under continuous improvement. So in the following slides, I'm going to present to you some preliminary results that we have obtained by reprocessing all the BGP data from the past 5 years, from 2019 up to 2023. But first, let me give you some high-level background on how GRIP works. So the events that we are targeting, such as those that lead to route misorigination and route hijacking, they generate specific type of events, such as a MOS prefix, a prefix that is announced by more than one ASs, or a sub-MOS one, which is the same but for a pair of prefix and sub-prefix, or even the appearance of a new edge in the AS level topology. So GRIP, using the BGP data from RIPERS and Routless, it will detect all of these BGP events, and then to each one of these, it will add informational tags based on additional datasets such as KDS AS rank and RPKI in order to build a more complete and multifaceted picture of the event. Finally, we have tailored a big set of rules which examine the assigned tags, the assigned informational tags of the event, in order to eventually classify it as a legitimate or as an incident. So let's see what we have found so far by focusing only on the events that lead to route misoriginations, namely MOS and sub-MOS events for IPv4. So first, some high-level findings is that GRIP marks most of the BGP events as legitimate, and the remaining 15% is marked as incidents. Most of the incidents exhibit patterns of misconfigurations. These include fat fingering the advertised prefix or the origin AS, as well as the common AS path prepending mistake. But we also see some RPKI-related misconfigurations where even though all the origin ASs are obviously related to each other, not all of them are covered by ROAS in order to be authorized to advertise the prefix. Then only 2% of the events exhibit patterns compatible with attacks, and another 2% might be attacks, but we don't have any clear indications to explain their nature, and that's why we also call them unexplained. So if we look into the data in terms of absolute numbers and at a monthly granularity from 2019 to 2023, we start seeing some very interesting trends. First of all, some very good news is that misconfigurations seem to have been decreasing. And even if we break them down into the different types of misconfigurations, we see that this decrease is actually dominated by the decreasing trend of the prefix fat finger mistake. Nevertheless, we see similar behavior for the other types of misconfigurations as well. For example, the AS path prepending has also been decreasing across the years, except for a spike actually during the pandemic. Okay. Okay. Okay, so now let's take a look at the other category events, the events that might be actual attacks. Here, unfortunately, we see that they remain somewhat steady across the years. So, but if we break the attacks into its two components, namely the events that exhibit patterns of attacks with the purple line, and the events that might be attacks but we don't have any clear indications to hit at the nature, the blue dashed line, we see that the unexplained events have been decreasing over the years, while the attacks, those events labeled as attacks, have been increasing. So we wondered, where does this inversion of trends come from? And we found that it is largely due to RPKI invalids. So indeed, here, with the red line, we visualize the growth in the RPKI ROA deployment. And we speculate that the increase in the RPKI ROA deployment correlates with the inversion of the trends that we saw in the previous slide, because now it allows us to mark an event as clear incident due to the RPKI invalids. So a hypothesis that we validate here is that actually RPKI provides more visibility into PGP events, which is intuitive, but still very good news. And this is all thanks to you and the community who have been pushing for RPKI and who have been publishing ROAs to protect their network spaces. So finally, as GRIP is a system, and we want to keep improving it in order to increase its utility for the community and for all the users. To do that, one very important first step, is validation and feedback from network operators. Because after all, network operators are the only ones who can tell us for sure what happened to their networks, or at least let us know of the nature of the event, whether it was legitimate and intended, or was it a hijack or a misconfiguration. Then GRIP is a very complex system to operate, and it requires developers and researchers to improve and implement the detection and inference methodologies. And of course, this requires more funding and more human workforce to be able to support the system. And I would like to close this short talk with a more actionable note. It takes a village, including you, the whole community, from network operators to researchers to policymakers, to build a reliable tool that will help us understand what is happening on the internet today, with the ultimate goal of improving its security and ensuring its integrity. And that was all from me. Thank you so much for your attention.